In our previous video, we talked about graphing linear inequalities, and now we're going to talk about graphing systems of linear inequalities. So I'm graphing 2 by 2 systems of linear inequalities. Nothing here really changes. The only thing that we're dealing with here is we're trying to see how linear inequalities will interact with each other. And by that I mean we're looking to find the regions of the graph that satisfy both of these linear inequalities at the same time. Okay, that's what we're looking for here. So to start with, we have y is less than 4x minus 3. So what we're going to do is we're going to start by graphing each of these linear inequalities as if they were equations, just like we did before. So we're not going to do any shading yet, but we are going to go ahead and graph each of these as if they were equations or lines, but with the appropriate style of line, right? So this first one, we have y is strictly less than 4x minus 3. So we're going to start by going down 3. 1, 2, 3. Okay. And we have a slope of 4. So we're going to go up 4 to the right 1. So up 4 to the right 1. Go up 4 to the right 1. And we have y is strictly less than 4x minus 3. So that means we're going to use a dashed line here. Okay, just like we did in the previous video. Okay, and now we're not worried about shading anything yet. All we're worried about is just getting the line on the paper now. Okay. Next, we're going to graph y is greater than or equal to negative 2x plus 9, and we're going to graph that as if it was an equation with the appropriate line. So let's switch over to blue for this. Okay, so we have y is greater than or equal to negative 2x plus 9. So we go up 9 on the y-axis here because the y-intercept is 9. And we have a slope of negative 2. So that means we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and keep doing this as long as we want, right? Okay, and we're going to use a solid line because we have y greater than or equal to. So we're going to include the line as part of our graph. And so now what we're trying to do is we're trying to find the region of the graph that is going to satisfy both of these linear inequalities at the same time. Okay, so before we do this, let's go ahead and just figure out which we would shade for each of these, right? So let's start with the top one. We have y strictly less than 4x minus 3. So we graph everything beneath that line, so to speak. So for here, we would graph so here we're going to graph each of these. We're going to graph everything beneath this line, right? Okay, and then for y greater than or equal to negative 2x plus 9, we're going to graph everything above that line. Okay, so if we're looking for the region that these two have in common, we'll find that it's going to be this region right here. Okay, this region right here. So what we're going to do is we're just going to shade this portion of the graph. Okay, so this is the region that's going to satisfy both of these at the same time. So it has to be beneath the pink line and it has to be above the blue line. Okay, and this is the only region that's going to satisfy both of those at the same time. If you were to try and graph this region here, it would be above the blue. It would be above the blue line, which is what we want, but it would also be above the pink line, which we don't want. And then if you were to graph this region here, it would fail both of them, right? It would be beneath the blue line, and it would be above the pink line, right? We don't want that. And then if you were to graph this region here, yes, it would be beneath the pink line we want, but it would also be beneath the blue line, which we don't want. So this region right here is the only region that we actually want to shade. Okay. Another way that you can do this is you can actually just go ahead and graph each of them and then shade the appropriate region. And then you can go back and erase the parts that you don't need. That's also a totally valid way of doing it. So you just see where they overlap and erase anything that isn't overlap. Okay. So if you If you're having trouble figuring out which one is the appropriate region, that's also a totally valid way of doing it. Okay, let's do one more. Here we have y is strictly greater than 3x plus 8, and we have y is strictly less than negative 3x minus 5. Okay, so let's graph the first one. So we start by we're going up 8 because we have a y-intercept here of 8. So up 8. We have a slope of 3, so that means we're going to go up 3 to the right one, but it looks like here we're going to run out of room, so we're actually going to go down 3 to the left one. Because remember, that's the same thing, right? It's the same thing as going up 3 to the right one like we did here, but we're going to go down 3 to the left one, down 3 to the left one, and we can just keep repeating this, okay? But now we have to look at the style of line. Here we have y strictly greater than 3x plus 8. So we're going to use a dashed line. Okay, and that's what your line is going to look like. Okay, so then we have y is strictly less than negative 3x minus 5. So we'll start by going down 5. And we have a slope of negative 3. So we'll go down 3 to the right 1. Or this is the same thing as going up 3 to the left 1. Okay, 3 to the left 1. And we have y is strictly less than negative 3x minus 5. So we're also going to use a dashed line for this one. Okay, so that's what these two lines are going to look like. So we're not going to include either of these lines in our shaded region. But now we need to figure out which one satisfies both. So we want everything that is above the pink line and everything that is beneath the blue line. So everything above the pink line, that would be this whole region here, okay? And everything that is beneath the blue line, that would be this region here. So this leftmost region is going to be the region we want to shade, and only that region, okay? And again, if you're having a hard time